today. And I will request Mr. Ishan, who is the head academic counselor of Ajeenkya DY Patil University, to take this further. Ishan, over to you.
Thank you, Avinash. Good morning, everyone. We welcome you again for this exciting webinar on uncovering the skills in demand in India's growing and potential infrastructure and renewable energy industries. I'll just share my screen. So today we have Mr. R. Balasubramanian, who is the lead subject matter expert for civil engineering at L&T EduTech. He has done his master's in structural engineering from IIT Madras and has over 35 years of experience in design engineering of steel and concrete structures for various petrochemical plants, process plants, manufacturing facilities, including automobile and food industries. He has also worked on pre-engineered buildings, precast structures, commercial complexes, both in India as well as in overseas. So his area of expertise basically lies in structural behavior, pre-engineered buildings, biophilic design, design management, and design thinking. Then we have Mr. KK Jembu Kailas, who is the lead subject matter expert for electrical and electronics engineering at L&T EduTech. He has done his engineering in electrical and electronics engineering from the College of Engineering in Guindy. He's the former head for engineering for substation and power distribution at L&T. And he has also done he has his own integral part of L&T projects for 36 years in various senior roles. Talking about his expertise, it lies in design and project planning, execution commissioning, and he has also done various projects on substations, industrial and building electrifications. Over to you, panel.
So, Ishan, if you can stop presenting, and I will request Mr. Jembu Kailash to start with the webinar presentation. Over to you, sir.
Hope my screen is visible.
No, not yet, sir. I think you need to present it again.
Oh, okay.
Yes, sir. Now it is visible.
Hope now it is visible.
Yes, sir.
So my voice is audible?
Yes, sir.
Absolutely.
Yeah. So thank you for a nice introduction on this topic and on also about me as well. So I am with L&T for 35 years with different areas of engineering. And today I'll be talking about renewable energy and power evacuation. Today, which is a very hot topic, even from government side or the private side. See, I'll be supported by Mrs. Shiva Prasad actually. So in between, we may have some conversation on different topics, highlighting on certain aspects actually. So this is where our presentation will be going on. So I think I'll be planning for an hour of presentation. Maybe afterwards, we can have some means clarification of doubts, etc. Okay, so let us start with this presentation. So the contents are like this: overview of power scenario, different type of renewable energy sources, solar energy, wind energy, hybrid. So basically, I'll be focusing on solar and wind. and different aspects of solar, and also what are the issues. See, always people talk about renewable energy, but what are the issues in the grid of renewable energy also will be talking today actually. So as you know, today the installed capacity power as on April 2023 is 409 gigawatt is in Indian installed capacity. Out of that, if you see 50% are from the coal, actually, that means from the fossil fuel, and another 6% that is from gas, again a fossil fuel, and a little percent on diesel, and nuclear is 2%. Then hydro is 11%, and renewable is 31%. So even today, the almost our renewable is 31 plus 11. If you include hydrogen, it is around 42% are from renewable energy, and around 58% are still from fossil fuel actually. So that is a scenario as on April 2023 of India actually. Now, what is the, I mean, as on 2021, the scenario was total, our requirement was 393 gigawatt was the installed capacity, and out of that 53% were from renewable, and sorry, from fossil fuel or the coal actually. So around balance is from renewable energy. But our plan is around 2023. Plan in 2030. That means our forecast is, or our plan is that almost we expect that our power capacity will almost doubles. So today we are around 400 gigawatt, and around 2030 will be around 817. That means almost it is going to be doubled. And solar, it is going to be around almost 50%. See, from 40% we may go to 50% of solar. That means we see 34 plus 17, around 51% will be from. So almost 50% will be renewable, and 50% will be from fossil fuel. That is going to be your the prediction or the plan or forecast by 2030. So government is giving a lot of emphasis for renewable energy due to various reasons actually. We'll see that. Why we have to go for solar or the renewable energy? Because all know global warming. Many forms we are witnessing, we are experiencing the global warming in different forms actually. Then another thing is fossil fuel depletion. When one time this is going to deplete the fossil fuel. Another one is again net zero emission target by 2070. We have target net zero emission, but net zero emission again related to global warming only. Now flooding of rivers and flooding of areas today, and fire and hot means a drought. These are all the things we are seeing, experiencing worldwide. All this because of the global warming things actually. That is the reason worldwide, even every country is working towards reduction of global warming, so reducing fossil fuel, etc. So that is the reason we are giving a lot of emphasis on renewable energy. So what are the different type of renewable energy? Solar is one renewable energy, wind is the other one, and you have geothermal is there, and you have tidal is there, then biomass, then hybrid. So different type of renewable energies are available. And today we'll be focusing solar and wind actually. But this all the major chunk is from solar and wind. And solar energy, you can say, that solar photoelectric voltaic system, that is what we are using for solar, one of the method, and concentrated solar, that is directly from the heat. But solar photovoltaic system, that is from the solar irradiation, and concentrated solar power is from, you can see, directly the heat we are trying to use for heating some, the liquid or molten salt, etc. to heat. So this also can be used for storage of energy. And solar thermal, we know already, which we are using for heating water, etc. We are using holes. These two are directly from the heat. But the solar photovoltaic system is the radiation is converted into electricity. Actually, solar radiation you are transforming into electricity. See, solar voltaic system, what's happened? Solar cells that convert sunlight into electricity. That is why we are calling as photovoltaic cells. So you have got an incident light. There is a PN junction, and you have got a semiconductor where incident light is, and the semiconductor absorbs energy, and ultimately electrons are generated, which is forming of current. That is principally behind these semiconductor devices. So silicon is the main semiconductor material used. Actually, maximum 99% are from silicon, and this photovoltaic cell has got a life of around 25 years. So 25 years, it can give 100% of efficiency. It can give the full efficiency, or its performance will be, it can give 100% performance. But after 25 years, the performance will come down. Maybe you may get slowly 80% like that, but the minimum 25 years, you'll be able to use that actually. So cell, a set of modules can be connected to form an array actually. So different cells form a module, and different modules you form an array, which is generally we use as a panels, etc. These arrays called panels. So here you form in a different number of, in a module you'll have maybe 36 cell constitute a module, and different modules you can make array kind of things. And also you'll have different type of connections. Actually, you can see on the right side, I can show with pointer. So you can see that this is cell 1, where the voltage is 0.5 volt. Cell 2 is 0.5. So if you connect all these cells in parallel, you'll get 2 volt actually. When you connect cells in parallel, you'll get a voltage. You can add the voltage, you'll get a total voltage. And similarly, here in a module, if you connect all the cells, here almost around 36 cells are there. And if you connect all the cells in series, you'll get if each cell produces 0.5 volt, you'll get around approximately 18 volt. So if you are connecting the cells, such panels or such modules, if you connect it in parallel, so that means each module, if you say like this, 12 volt modules or 18 volt module, maybe let us take a 12 volt module. If you connect in parallel, if each module can carry 5 amps, then totally it will get around 15 amps. It can carry actually. So when cells are connected in parallel, you can add the currents. Actually, the total current will be going to be the addition of each cell actually. But voltage is when you correct series, you will get a total voltage going to be addition of all the voltages. That is how. So this formation, so module can be connected in combination. Generally, we do based on our requirement. We can have a combination of parallel or series connections, or both. In some places you have to use both, some places only in series. So different methods are there so if you want to have a very high voltages, then you have to connect all the modules in series. If you want a high current, then you have to connect modules in parallel. If you have both, then you have to connect it in combination of both series and parallel. So these are all different ways of connections are there. You can, here it is, everything is connected in series, each things. And different ways of connections are parallel arrays are there. This is called array actually. When you connect each module, this form, it is called arrays. Then in the module, you have got monofacial. Monofacial is what? Because one side only, you have got a, I mean, the semiconductor is there. So this is on the one side. Other side is it's a it is opaque thing. No, no light can go from the other side. Okay. Now other one is bifacial. That means both sides of you have got a material. Solar voltaic cell is there on both sides. So that means both side it can generate electricity. Okay. So if you have a bifacial, you may think that if here it is producing 500 volt, 500 watt, then if you have a both bifacial, you'll have 1000 watt. But it is not so actually, because bifacial cannot produce double the voltage or the power produced by monofacial. So the bifacial can produce maximum comparatively 30% more power compared to monofacial. So we can increase 30%. Cost wise also, bifacial is bit higher than the monofacial, but bifacials are used where land cost is huge, or if you want to accommodate in a specified area where the land is an issue, you can use bifacial. This is a monofacial module. You can see there is a glass and monofacial solar cells, and backside is opaque, so no light can pass through that. But in the bifacial model, you have a glass. It is a kind of sandwich type of thing. So the solar cells are sandwiched on both sides, so that both sides it can produce electricity. Here it is a bifacial solar panel. So directly also the the solar energy is radiating, and also from the bottom actually. So here again, it depends upon how good your surface is there. Okay, if the surface is white, it will reflect very good. And to some people, I mean, there are some projects where we use even reflectors also on the bottom actually, so that it can reflect maximum sunlight from the due to reflectors. Okay, so maybe glass reflectors or a kind of aluminum reflectors are used at the bottom of the cell, so that it can produce more power or voltage, etc. Okay, so you can increase the efficiency of the solar panel actually by using reflectors. But in some of the areas where snow bound areas where, so still these are all advisable, because at least if the snow is filled on the top of this cell, the at least bottom will produce electricity. It may not be 100% nil actually. That is the advantage of. So based on the area, based on our requirement, we can select whether it is which is advantageous. We have to select. These some of the different type of cells and how it is transformed actually. Earlier it was 350, 375 watt. Today the cells are producing 640, 660 watt we can produce, or even cells are available with 800 watts also. So the technology is increasing and day by day, and solar efficiency is increasing, because one issue with the solar is you require a lot of land areas actually, because land area is also costly. So if you can produce good electricity in a smaller area, that is advantageous actually. See, when you decide a plant cost, you have to consider the land cost also. Okay, not only this. So when this become more efficient, then you can reduce the project cost considering the lesser footprint, etc. Okay. So technologies means advancing, material science advancing. This is some two curves actually. Here you can see that see two curves are there. One is IV curves, current and voltage curve, and power voltage curves for a sample PV module of 390 watts. So when generally the peak sun hour, if you see the peak sun hour is nothing but 100 watt per meter square is called peak sun hour. So that is the maximum sun radiation or sun irradiation you will get from sun. So that may not happen constantly throughout the day. Maybe it may be so for 4 hours or 3 hours, etc., depending upon the climatic conditions or clouds, etc. So the maximum 1000 watt per meter square, the maximum radiation what you get from the sun, that is called peak sun hour actually. So that may happen maybe in the mid of the day, or so when the sunlight, the radiation increases from 10 o'clock and may by the time 4 o'clock it may reduce it. So it will come down. So slowly it may from 200 watt increase to 1000 watt, and for again from 1000 watt per meter square it will started reducing. Okay, then come down to and become zero the night. That is how the sun radiation you get it. So we get around the around 5 hours, you can say peak sun hours we get, that is very good. Okay, average if you can get, that is a very good area actually. So if you consider 1000 watt per meter square thing, then you will get a 12 ampere current. This one 390 watt module. But if the sun radiation is only 800 watt, again it is getting reduced to 10 amps. 600 watt reduced to 7 amps, 200 watt 2 amps. Okay, so the current will reduce based on the intensity of the radiation. Actually, if you get an excellent radiation, you will have better current. But radiation reduces, the current also will reduce. Similarly, if you see the power also at 1000 watts per meter square, if you get this is for a particular solar module of 390 watt solar module. And we are seeing the characteristics of the cell, how it behaves. So when 1000 watt per meter square, if you get the power output is around 390 watt, and if the radiation is coming down 800 watt per meter square, then it comes down to around 320 watt. And if comes down to 600 watt per meter square, then your output is coming to around 250 watt, etc. So your output depends upon the peak sun hours actually. So if the peak sun hours, or rather how much radiation you get from sun, it is not the heat we are concerned. We are concerned with the how good the radiation you get. Okay, so the electricity or the electrons are liberated based on the heat, based on the radiation. So or based on the energy which will be absorbed by the semiconductor. How much it absorbs energy, that much you will get the power or the current or the voltage. So, okay, that's what this graph shows. So if you get an excellent peak, then you will get a better output. So this is all some of the arrangements of PV panels. You can see this is taken from some of the L&T sites actually. So you can see here how the panels are laid. The panels are kept fixed on a framework of steel actually, and with a footing also. There is a foundation for that, so that it should not fly away with the wind, etc. It is fixed to a framework and it will got a foundation, etc. Okay, so it is kept in some particular angle. Similarly, you have got array of these panels are there, and these are all connected, and the current will be taken to the inverter, etc., which I will be explaining. These are the things. So here, what you can notice that it is going along the profile of the land. Okay, so whatever may be the contour of the land or the level of the land, we are not leveling it. Along with the level of the land, we are also going with this. That is what we are showing. This is a hillock actually. See, along the profile of the hillock, these panels also kept. Okay, so we need not even it can kept on the slope, or it can be valleys, etc. It can be kept. Here you can see there is another arrangement. So one point what you have to see that here, one thing is that we have to calculate, while calculating the number of cells, you have to consider the shadow also, because so many trees are here. plants are there. So when the sun position changes, it is susceptible to have shadows, and the moment you get a shadow, the output of that cell of that particular area will get reduced. So while calculating, we have to take care of all these things. Now solar inverters, let us see. This is one of the, probably you can say, heart and brain of the solar system actually. So as you know, the inverter means it convert DC. So it produce DC current, and this is converted into AC by inverter, and you are exporting to the grid. This is what this diagram shows actually. This is a combiner box. You take all these, or you can say pooling, you pool all these things, and it is going to the central inverter. Similarly, you have got a string inverter, that is decentralized one is there. Some groups of inverter you can have, rather than keeping central. Here itself you can have groups inverters, and you can have this AC connection, and you can take to the grid. Here you should understand that the duty of the inverter is not only to conversion, this acts of the brain actually, because this only is getting synchronized. This through inverter only you are synchronizing your system to the grid actually. So also it is take care of the grid changes actually. Grid voltage fluctuations, grid voltage, even the frequency changes, voltage, everything. Accordingly, this inverter will adjust its output also, because so that always will be there with the synchronized with the system actually. Unless there is a major fault, this inverter will be always try to synchronize with the grid. So you should understand one thing, that see, this is not producing the like a black star kind of things. So from the grid, you have to take the power supply from the grid, and this central inverter will synchronize with the grid voltage actually. Okay, so it will see the profile of the voltage, or the means the frequency, etc. It has to match with the grid frequency and match with the grid voltage. Then only the system can be synchronized. So entire work is done by the inverter actually. Okay, these things you should really understand. So this plays a very vital role in exporting the thing, and also to maintain the synchronism. That is very, very important actually. So if any fluctuation in the grid or anything, it does not go out of the thing. This also one of the requirement of grid code from the government actually. If inverters, if the solars and renewables are going out from the grid due to any voltage dip, etc., then it will go to disaster. Maybe this may affect the grid stability. As we are having more and more renewable energy systems are into the grid, means if the renewable energy is going out of the grid or going out of synchronism, then it will have a lot of fluctuation in the system, and it will affect the grid stability. Okay, so one of the requirement is that it should always remain with the grid actually. So all these things, this inverter will take care, and also this take care of reactive injection also, whether it is reactive power injection also, this inverter will take care. If due to, suppose, for a voltage dip where the inductive reactance is very high, then it will inject capacitive reactance, and it will still maintain the grid voltage level. Voltage sag and all, it will manage. So it has got a lot of, today's inverters has got a lot of lot of features are there with the inverters. So that main configuration of grid, I told you that grid tied systems. You have got directly grid tied system, off grid system. That means it's as good as a standalone system, and hybrid system. So different types are there. Now we'll say some stuff of the how to design a solar power system actually. So first, what you have to do, you have to survey the area where you are intended to put your area, or you have to select the area which is best suitable for your own solar power production actually. So you have to visit the site, and you see what are the things, maybe as I told you, whether shadows are there. So every aspect has to be taken into account, whether the land profile is low PE, or it's a flat area, or is there any problem of water flooding. Every aspect has to be checked. That is the first. Then you have to do the load analysis. You should say what is the load pattern, and how load constitutes what actually. So every information, and what is going to be your demand, you have to calculate. What is going to be the maximum demand of the load in a day. So that you have to calculate. That is going to be your input. Then you have to design the solar PV array based on the load requirement and also based on your radiation level of that area. So every aspect you have to consider. The radiation level you have to calculate, and also what is the power requirement. Both you have to take it into consideration, and you have to calculate the PV array. There are different calculations available, and we have a lot of softwares also available. PV Assist is one of that software, or SAMS is another software, wherein we can design a system, and every aspect in the software we can take into account. That is your requirement, and so, the shadow analysis, every aspect, even inverter sizing also can be done. Okay, so inverter sizing based on your power output, also we have to take care of inverter characteristics. So you have to see in the market what are the different type of inverters available. We have to find out its characteristics, and you have to match with your own power requirement. And this selection is again a many intelligent process, and we can manually select, or we can through PV system also, or software also we can select, because software also will have data of what is available inverters in the market. Then sizing the battery, which is another important thing actually. Sizing the battery, you have to, again, it depends upon the storage days. How many days you would like to have storage? That all these things you have to take into consideration for the backup. Then next is the connected to the grid interface. The grid interface, very important thing, what you have to note that at what voltage level you are going to synchronize your system. That you have to see actually. And you have to have a agreement with the electricity board, because you have to connect to the electricity line. So what is the line available nearby? Accordingly, you have to check, and also how much power you are going to produce. Your voltage also depends on how much power you are going to produce. Suppose you are going to produce 50 megawatt power, then you have to go for 220 kV level of system. You have to go. You cannot synchronize with a normal 11 kV system. Okay, this is the thing. We have to have a good study for grid connection. So if you are only 1 kilowatt, then there is no problem. You can connect directly to your 11 kV line or 415 line. But if it is more than that, 10 megawatt, etc., you should also discuss with the EB, and accordingly you have to select the inverter. Okay, then you have to select your transformer also. You have to have inverter transformer and inverter. Everything you have to select based on the power you are going to produce, as well as at what voltage you are going to connect with the grid, which is a very important job actually. You should be in agreement with the electricity board on this. Shiva, would you like to add anything on this? Shiva Prasad? Shiva? Okay. So this is a grid-tied solar PV system. You can see solar panels, inverter, as I told you. So the solar panel converts a DC to AC, and this is basically a, maybe we can say, a rooftop solar kind of things, where you have got a inverter and you are taking to the home. Then you have got a smart meter. So the smart meter, see, whenever you require, you can take from the grid. But if the solar this is not sufficient, you can take power from the grid. Also, you can export to the grid. That is why this meter is a smart meter. It is a two-way meter. You can have a two-way power supply flow. It will account in both the directions, and resultant you have to pay actually. And what are the components in the grid connected PV plant? You can see this is a solar array, which is a primary component, and you have got a tracking system, which we'll be talking later. And you have got the wirings. Then you have got inverters, meter, and controllers, etc. Okay. Now SCADA is also used nowadays to monitor the performance of the cells, performance of the PV modules, and performance of the inverters, etc. So we can, from remotely, we can also monitor the healthiness of the system. This is the off-grid actually. Off-grid, you are not going to export any power supply. This is, you are going to store in the battery itself. So whatever you are producing, you store in the battery and you can use it. Here, you are not connecting the grid. So you are standalone. This is totally standalone. Even there are some houses also like this. They don't depend on EB supply. They don't have EB connection, but they are still living with the solar panels. So PV string connected to inverter. So you can see this is the inverter actually. As I told you, you can have a centralized or decentralized kind of thing. Inverter is possible. So these things, here it is getting converted into DC to AC, and it will go for a pooling station where all the voltages, all the this thing will be coming there actually. This is 3.125 megawatt central inverter, 5 megawatt central inverter. These are all very huge capacity inverters actually. 5 megawatt to achieve from solar, you require a lot of solar cells. Okay. This is a string inverter, means it is a decentralized inverter, 250 kilowatt. Skid type inverter, you can see 9 megawatt capacity. Now we can see this tracker. Actually, what is tracker here? So the top here you can see that the cells are fixed actually. This is not movable. See, even though the sun position changes from east to west, the sun travels, but your angle, no, when sun is at midday, you will have a better radiation. But when sun moves, the radiation level will come down. Okay, so if you are using a tracker kind of thing, you can say here, when the sun is at the east, entire panels will be turning towards east. If you can. Similarly, if it is at the center, it is at the toward the sun. So always the panel's direction will be changing according to the movement of the sun actually. If that is possible, then you can see from the graph that at least 35 to 40% of the energy you can get a increase in energy comparing to fixed one. Okay, that is what the experience shows actually. Okay, by using a tracker, we can increase the energy output at least 35 to 40% of the conventional, the fixed one. So it will have a lot of advantage if you are using a tracker. See, this is the tracker. Tracker, two types are there. Means single, one in portrait, 1P tracker. This is take care of one row only. You can say here it will take care of one row. If you have two rows, you put your tracker here at this in the gap of the two rows, and you can use it. It's a single tracker for two rows, or one row, one tracker also can be used. But here in this case, your motor capacity will be little higher compared to this one actually. So two different trackers are there. You can see the picture how people are fixing. This is one of the L&T's project sites where they are fixing the tracker. So this is a robotic cleaning system. So we have got robot. This is the robot arm actually, which is cleaning the solar. So one point you should know that, see, if the dust accumulation is one of the things which will reduce the efficiency of the the cells actually. If more dust is there, then your efficiency will come down. So we have to have frequently, we have to clean the system. See, some places we do manually with the water sprinklers also we can clean. Manually it can be cleaned, or we can use a robotic arm. The same thing based on the dust accumulation, automatically this will be cleaning. So there are different systems are available for cleaning the system, but cleaning the system is very, very important actually. Otherwise your output will come down. So there are different mega solar parks or ultra mega parks are there in all over India actually. Maybe you would have heard these Kamuti solar project, Karnool mega solar, Pavagada solar. So different states they have got a massive solar projects is there by. Now grid tied or on-grid system, we can see what I saw earlier. That's a schematic diagram actually. So you have got a solar panel. There is a inverter where you are converting DC to AC, isolation switch, then AC circuit breaker, and you are using for your own household equipment, and balance your through electric kilowatt hour meter. It's a smart meter you are supplying to the grid. Okay. So these are some of the installation actually. 60 megawatt solar power plant in Gujarat installed here. This is a fixed tilt only. There is no tracker actually in this. This is another 340 megawatt solar plant at Tamil Nadu, somewhere in South Tamil Nadu. This is, you can see here 340 megawatt means how many cells, sorry, how many arrays you have to use. So you can just imagine. So much area is required for this. This is 300 megawatt solar plant in Saudi Arabia. You can see here. And this is 1 gigawatt. This is huge plant actually, because there in Saudi Arabia, got a lot of land is available where non-grazeable or desert area. But there again, one disadvantage is that you can sand dunes are the another issues actually, because the top of the solar cell will be covered by sand due to sandstorms, etc. That is one of the problem there. So you have to clean the cells very often actually. That is one of the problem. This is another solar 20 megawatt floating solar plant in UP actually. This is on the reservoir, the plant, this is floating. Another one is 4 megawatt floating plant in Andhra Pradesh. This is in Tirupati actually. So in this, no need of land. You can see the water bodies you can effectively utilize, because otherwise you use only for irrigation or this purpose. And this is advantage. And here you can less evaporation and algae bloom, easy for maintenance, and most important thing, it will maintain the solar cell cool actually. Because we can see that further. So when the temperature is coming down, the solar cell produce more power actually. That is the advantage. If very high temperature, I can show you next characteristics. So it requires a good radiation, but the temperature is always, if it is lesser temperature, it will produce more power or voltage. That is the advantage. Now let us see what is the potential, because today government of India is talking high about this solar potential at Leh and Kargil. This is an area they are expecting a lot of potential. This is supposed to be the most ideal for solar actually. Why? Because you get maximum radiation there, but at the same time, temperature is very low. It goes to minus like that. Okay. So or otherwise it is called cold desert. Okay. So here nothing grazeable land is there. So this is the best area for solar, or you'll get maximum. So huge non-grazing land, low temperature going minus, and high solar radiation in cold arid region with the 5.6 kilowatt hour per square meter per day. Okay, then 320 sunny days are available. So 5.6 peak sun hours per day. Okay, so this is the average, where the peak sun hour is defined as 1 hour in which the intensity of sunlight averages 1000 watt per square meter. That is called peak sun hour. So here you can see how much such peak sun hour. See, in June, you have got around 6.5 peak sun hour, and September it is almost 7 peak sun hour you are getting. So that means 7 hours you are getting 1000 watt per meter square. That means maximum output you are going to get, but it will come down. In December it has come down, and January also it is less. But around July, August and all you are getting. So average in that Kargil location you get 5.6 peak sun hours. Is an excellent thing. Here you can see the graph, the performance of the model. You can see that you take a cell which is particular cell which is producing 391 watts at 25 degrees centigrade actually, but at 10 degree it is getting 411.6 watt. So when the temperature is less, it is producing 411.6 watt. When the temperature is increasing to 40 degree, it is this output has reduced to 370. At 55 again, it reduced to 348. At 70, it reduced 326. So temperature is very important factor for a solar system. This I mean solar cell. So incident radiation, the incident radiation, even though we are getting 1000 watt per meter square, but when the temperature is going high, the output is coming down. Whereas another example here is say here the cell temperature is at 25 degrees centigrade. At incident radiation of 1000 watt per meter square, it is getting 391.1. But incident radiation, when it reduces to 800 watt, it is 313.5. It has reduced. But whereas here, if you can see here, the cell temperature is 45 degree. But here, when we are getting 31.1 at 1000 watt per meter square, here at 45 degree, your output is 362, whereas it was 391 has become 362. Okay, so temperature is playing a major role actually here. So if we can reduce, if we can go to temperature, so the ideal place is that we should have excellent radiation. At the same time, temperature should be low. So for that, the ideal place is Leh Ladakh area, where you get a better radiation of 1000 watt per meter square. At the same time, the temperature will be below 10 degrees centigrade. So you'll get maximum output in Leh Ladakh area. So government has planned around 7.5 gigawatt in Kargil and Ladakh area. And they are in the whole area, they are expecting around 35 gigawatt. But here the challenge is that the transmission of all these things, how to transmit this power, so much of power from such a hard areas. That is the biggest challenge actually. You can see how the areas are there. So it is so naturally you cannot transmit everything in such a heavy power, high power through AC system, because that most of the areas you cannot take cables or transmission lines, because means hilly areas, many areas you cannot take a transmission line, cannot be transmission structure cannot be erected. So the only option is to go for HVDC is the only option where I can use cables. But AC, if I take cables, I got a limitation. See, maximum I can take around 100 meters only in AC I can go because of the reactive power, etc. But in AC, HVAC I can go. So the only option is that in Leh Ladakh area I can see. So first you have to go for AC. You convert AC to DC, from DC to AC, and you connect everything in a pooling station. And there is a HVDC convert station, and you evacuate the power, and again you convert back to AC. This is the only way it is possible for such an area. So the challenging part is you get, even though a lot of power, but transmission of power is really a challenge. But still the discussions are these are all going on actually with the people. Now let us go to wind. Shiva, you are there? Shiva Prasad?
Yes, sir. Yes, sir. Yes, sir.
So wind is another area. You can see the turbine. You can speak on wind, Shiva?
Okay, sir. Okay, sir.
Yeah. Yeah.
Actually,
Yes.
wind is of two different types we are having. One is onshore and offshore. So the name itself, it is saying that onshore and offshore. So one we are going to use the land, and another one we are going to use the seashores. Is that I can share the PPT, sir?
No, you can see from here itself.
Okay. So
In this order you can speak. Yeah, you can start with the turbines. Yeah.
So basically, there will be two different types of turbines. One is horizontal axis wind turbines and vertical axis wind turbines. The most usable type of wind turbines will be horizontal type. So where they are going to use the blades, and these blades are using a aerodynamic principle. So that is which is used in aeroplanes. So whatever the principle used in aeroplanes blades, so that the same thing they are going to use. There are different components involved in making this horizontal wind axis turbine. So that is they have made with different structures. So if you are going with the offshore and onshore, so based upon the hub height, okay, so based upon the wind speed and based upon the height you are going to select. So based upon that, there will be different rotor diameters they are going to take. So there are different components. So that is based upon the hub height, the level of wattage, that is from kilowatt to some megawatt range. So that will depends upon the how much amount of height we are going to take. So that is the hub height is the main factor. So that hub height is taken into account, and it is if you see here, so the maximum it went up to 6 megawatt range. They are going to with respect to this horizontal. And the foundation, so whatever the foundation they have to make, so that foundation has to be taken care while laying the plan.
So here you can see that for 660 kilowatt, the height is around tower height is around 50 meter and the rotor dia is 47 meter. Similarly, for 1800 kilowatt, because one wind turbine, you are going to get 1800 kilowatt. The height of the rotor is 80 meter and tower height is 60 meter. So here you can say 6000 kilowatt, that means 6 megawatt, which is the rotor is around 120, the dia is 126 and the height is 138. This is how it is going actually. So see 6 megawatt and all on the offshore and these things are a big challenge actually. That is what is the limitations for this. And offshore, maybe you can see, so through sea they can shift it, but on the road, this is one of the challenge. Or for each blade is, you see, it is 74. I mean 104 meter dia and all. It will be very difficult to transport. Is one of the big challenges actually. Okay, now thank you, Shiva. Okay, now you can explain how the parts.
Okay, so this basically wind turbine will have a nozzle and a rotor. So this nozzle will contain the generator part and how to control this rotor, then some power electronic component along with a gearbox. So gearbox is not required. So if it is you can take gearbox into account or you cannot, but that depends upon the speed whatever it is going to get varied in that location. So the gearbox along with the why we are going to require the gearbox is, so if you are not getting gearbox, the turbine generator whatever we are going to use, that require more number of poles in order to generate the power. If you are going to maintain a constant speed by using a gearbox, so then the minimum number of poles are required in order to generate the power. Along with that, for measuring the speed, we are going to use an anemometer here for getting a record of the speed, and by which we are going to control the different parameters.
Yeah, thank you.
So here is another simple mechanism how to understand it. So here we are having a rotor. So rotor connected to a gearbox. So that is an optional one, which is connected to a generator shaft from which we are going to generate. So generally this generator will convert at a power at a different frequencies. In order to maintain that into synchronized manner, so we are going with the power converter that will make the grid required frequency, which is connected to a power transformer, and then we are going to connect it to a utility grid. So these are the some configurations what we have with respect to turbine generators, but most probably we are going to use induction generators with some starters, because if you are taking an induction machine, it will have some starting high currents. So in order to reduce that starting current, so we are going with the starters. Along with that, we are going to use here a capacitor banks. Why we are going with the capacitor banks is, it requires a large amount of reactive power, so that is a reactive currents are required. So in order to compensate that, we are going to have a capacitor banks at the wind turbines itself. this mechanism, whatever it is there, so that can be justified, or we can eliminate by considering a doubly fed induction generator. So where we can use the same power for reactive power compensation whenever it is required.
Yeah, please.
Yeah, actually, for wind selection, so we are going to first we have to look at the site and we have to take a continuous readings of data. So that means data has to be collected for 1 year, and we have to study what are the wind speeds by laying some wind measurement meters over there, and then we have to find what is the capability of power which can be used over there. So that is the what is the type of generator we can use and how much amount of energy we can produce in a particular area, we can justify. This can be also used by using some softwares like system advisor model. So where we can choose a particular location, but the limitation of this software is it is given only for the US locations, that is based on the NREL web page. So they are going to take the locations only for the US based locations. So still some softwares are there with natural customers like premium customers like Suzlon and all. So they have their own customized softwares where they are going to use for the site selection and how much amount of power they can generate using that particular softwares. There is a web page that is a global wind atlas where we can find that a potential of wind by this global wind atlas. So by it is like a online utility software. So where we can find the potential of wind in a particular location. So if you can go to India, so there will be a large potential in Tamil Nadu and coastal part of Gujarat area, and for the offshore. Whereas for onshore, so we are having in some parts of southern parts of India and Gujarat area where we have a, so you can look it here. So the seashores of Tamil Nadu and Gujarat area, so there will be much wind speed. So because of that, there will be some potential for more potential for offshore. So there is a some agreements between Denmark companies and India. So apart from that, if you see in the Coimbatore region of Tamil Nadu, so where we can see some red part here. So this is a potential where we are having onshore wind farms. So if you go to the near to Ooty, so and all, you can find more amount of wind farms which are there, which are of more capacity. So if you consider Tamil Nadu state, which is of largest producer of wind.
Thank you.
Okay.
Thank you, Shiva. Okay, now as he said, no, see, if you go for the offshore, actually, the higher wind speed with the consistency in direction, because you have got a constant speed, because as there is no obstructions there, the speed is very constant. And it has got a reduced environmental impact and more space you can use in the, you don't require any land, you can use the sea space, this one. So both are a lot of similarity, but major component of offshore wind is turbines, foundation, inter-array cables, offshore platform, substation, high voltage export, interconnection. Because high level of technology is required for this offshore. Actually, we should study about these are one of the BIM model, building information model, which you have made for an offshore wind farm, and with this is the offshore wind substation actually. Okay, so I'll coming to that. I'll come to you in the next slide. This is a BIM model what we made for a project for an offshore wind. So you can see these are all offshore wind turbines. It's a wind farm actually, and this is the substation, offshore substation. So this is going to be turbines are connected, and there are inter-array cables. Each turbines, maybe today turbines, offshore turbines will produce 6 megawatt power supply. Okay, 8 megawatt and all offshore wind can produce because it is on the sea only. So all these cables are connected through, which is called inter-array cable. Everything is connected and it will be connected to a offshore substation. So there, through we combined all these voltages and through a submarine cable. Okay, inter-array cable also submarine cable only. This is going to be a very high voltage cable, and from offshore substation through high voltage submarine cable, it will be connected to the onshore substation, and further it will be connected to the grid. This is the principle behind that. You can say here, these also very foundations are very challenging. Actually, it depends upon the depth of the sea. Actually, there are floating structures are there, and monopole structure, jacket tripod structure, different structures are there. It depends upon the sea depth and your the structure. Actually, you can see some of the photographs. These some of the connections, inter-array, how it is connecting. So these are all the turbines, and you are connecting in radial form, ring main form, different forms of connections we do. Everywhere we use this is one of the inter-array cable or submarine cable. It is a very highly sophisticated cable. Very few manufacturers are manufacturing these cables in the world. Actually, this submarine cable, it has got a lot of protection. Water should not enter. So many features are required here. These cables, you can see some of the how it is laying the cable. There is a floating the connections. So floating, what they do, there are buoyancy modules they are connecting. So this itself is a underground. I mean, submarine cabling itself is a big topic actually, and how inter-array cables are connected. So different different turbines are there. They are all connected through this, and they are connected to the. See, there are some cases where you can have onshore substation. If these things are within 20 kilometers, actually, if all your turbines or the wind farm is around within 20 kilometers, then we can have. We need not. We can have the substation. We can have the AC cable, and it can connect up to the substation on the shore. Actually, you can say this is on the shore. Offshore means in the water. Onshore means it's on the land. Actually, okay. So if the within 20 kilometer, we can have the substation on the land itself. Okay. Suppose if it is going beyond 80 kilometers, then we cannot have these. Actually, then we should have the substation here itself in the onshore itself. We should have a substation, and you step up, you collect all this will be in the order of 33 kV, all these 33 kV, and with a transformer, you step up to 220 kV, and you maybe you can take into onshore this one onshore cable join, and we connect to the substation. Actually, this is within 20 to 80 kilometers. If it is more than 80 kilometers, we cannot use AC cable. Actually, as I told you in the Leh Ladakh case also, the AC cable we cannot go beyond 100 kilometers. If it is going beyond 100 kilometers, naturally you have to go for DC only because of the reactants, cable reactants and other things, because of the nature of AC. Okay, so in such case, if it is going beyond 80 kilometers, then we should have an HVDC. You connect all the 33 kV or 36 kV submarine these generators. You connect to the pooling substation, and you step up to 220 kV, and you with an inverter you convert back to DC, and from on DC you on the land you'll have inverter will be there. You again convert back to AC. So if the distance is more than 80 kilometers or more than 100 kilometers, naturally you have to go for HVDC is the only option actually. So this will be more expensive. So when you are expecting more potential, then naturally we can go for this module, this kind of method actually. Okay, even if it is far away, you can say. But in Gujarat, we have seen in Gujarat and Tamil Nadu, they are all within 20 kilometers only. I mean, in Gujarat coast and Tamil Nadu, where Mr. Shiva was telling that there is a good potential for offshore. It is within 20 to 30 kilometers only. Okay, so we don't need for going for HVDC. This is some of the typical arrangement here. This is typical arrangement of that. This is how it looks like offshore wind platform. You can see all your things. No, it means 220 kV, GS, gas. We go for gas insulated substation here. We cannot have a conventional substation here. Then transformer This is GS, 60 kV GS container, then temporary diesel generator, so many things. Then there is a transformer here, step-up transformer. So everything you have to accommodate in a kind of a platform. And all these things are mostly prefabricated one. We cannot do any work on the platform here actually. So entire substation, generally it will be assembled at onshore, and you have to bring on wrapped, and you have to install here with some crane and other thing. Actually, wrapped itself will have a crane, and through crane you have to install these actually. So here no more work you can do. You are only going to connect only the array cable, whatever cables are coming from the arrays. So different array means different turbines, no wind turbines. You are getting the cable. All these things, only connection is done here. No other work can be done here because of the limitations in space and considering criticality of that area. So these are all highly assembled substation. Entire substation we have to assemble it and bring through raft, and you have to put it over this. Actually, that is how we do. This is one of the example. You can see the entire thing will be done then it will be installed here. So now, as he told you, there is a good potential in Gujarat. This is a Kutch area of Gujarat. It's a good potential here actually. And similarly, this is the area of Tamil Nadu also. Rameswaram, this area has got a good potential. So Kutch and Gujarat has got very good potential for offshore wind farm. So India government is also working on that in collaboration with different, as he said. Okay, so good potential is available here. This hybrid energy where you use solar and wind together also we are using many places, because daytime solar will produce power and nighttime you can get power from windmill, so that you can compensate. So continuous power supply is in it. This is some of the installation of ground mounted plant with this energy storage. That means battery energy storage system here. So this is in Andaman, which we have done it actually. So whatever producing energy can be stored here and you can use it. Then grid challenges, I told you. See, this grid is intermittent. Actually, you can see the picture. When the night you don't produce anything. Okay, nighttime you are taking from the grid. In daytime, you are producing this from the solar is producing during nighttime. So this is an intermittent thing. There is uncertainty. These are all the different issues. And low SC level, no reactive power supply. These are the problems with the wind. Even though we say renewable energy is good, but it creates a lot of disturbances in the grid actually. So we have to take care of all. There are a lot of issues it creates because the switching, different switching, it produces a lot of harmonics actually. Okay, so inverter is nothing but switching. Switching is happening. You are creating from DC to AC, artificial AC only. This is okay. It's not a natural AC. So it creates a lot of harmonics in the system. So similarly, even windmill also you get a lot of harmonics, etc. And solar, wind, etc. But in conventional, you can control your frequency when it is a high inertia load and limited starts up, low ramping rate. These are advantages are there in conventional, but in renewable energy, you have got a lot of different disadvantages like harmonic, etc. So what these challenges, how to address these challenges? That means variable generation, loss of synchronicity, these are the issues. Overloading, low flows, nuisance tripping, trip due to increase in short circuit current. Because inverters, many times when you short circuit current, inverter will trip. Inverter will go out of synchronism, it will go out of the grid. These are all the issues faced. And power quality like voltage and frequency fluctuation, VAR support. Even though today, to some extent, we are able to, through inverters, are able to supply VAR to the system. But still, this is a question. Harmonics are still is a question, actually. So grid, as per grid, you have to maintain the frequency for 10.52. This is the bandwidth, and total harmonics should be distortion should be TH3 less than 0.15 and power factor and low voltage ride through capability. Maybe what is the LVTC? LVRTC is low voltage ride through capability is that many times these inverters go out of synchronism. If any small voltage fluctuation or if voltage is sag, any voltage going low due to reactive power or something, then this most of the these renewable or the solar or wind will go out of synchronism. It will go out of the grid actually. Then what will happen? Sudden voltage, again further voltage dip will be there and grid will collapse. Already voltage is low. If all these renewable, because today we saw that around 40% renewable are there, more renewable penetration is there. If it is going out of the grid, then what will happen further? It will deteriorate the situation and it will affect the stability and it go for a blackout. Total grid failure will happen. That is the reason now this grid code is telling that should have a low voltage, I mean LVR TDC capacity should be there so that it will not go, it will still retain with the grid. Then solutions are, I told you solutions here are, you can go for a pumped storage, battery storage and STATCOM. These are the solution for this. So storage and STATCOM is the thing which government is using in a high level. Maybe many places where Pavagada and many places we have got a STATCOM project like Trichy and Tamil Nadu also you have got STATCOM and SVC, static war compensator, mechanically switched capacitor reactors. These are the things even power grid and power grid is using wherever heavy density of renewable energy is there. So there are places wherever I show you some areas where the high population of this is the renewable is there, where and all power grid is going for a STATCOM kind of thing, STATCOM and HVC, so that you can, to some extent, you can reduce the issues because of the renewable energy, because the voltage, the harmonics and the grid instability kind of things are to some extent frequency issues, voltage issues, grid disturbance are to some extent we are able to solve by using these static war compensators or STATCOM HFL. So ultimate digital solution is carrying out a system study. So system study you have to study. There are different tools are available for system study, and the close to monitoring of generation transfer and distribution to maintain grid stabilities. If we can do that. So today we have got different tools are available to. Then the supply demand, how much you can match, that also will. So you should not overdraw the power from your grid. So whatever demand is there, if you are able to supply, then you can maintain the grid as stable. Okay. Today we have got a lot of, I mean, monitoring systems are available. You can see these one of the plant SCADA, plant SCADA diagram architecture. So today we get data from weather stations, weather static, remote center, etc. SCADA get information so that we'll be able to predict also, because how much solar, few days, how much we are going to get solar radiation, or is there any chances of rain? Every aspect we can get information from the weather stations, and that can be integrated with your system so that you can have your own production, or you can propose your systems. You can predict your demand, or predict your productions can be predicted based on this weather data. So today we have got advanced systems are available. Okay. And also through SCADA, we can monitor the condition of inverter, substation, grid, every aspect, and even the efficiency of the solar, every aspect can be monitored, and we can also plan the maintenance. Preventive maintenance can also be planned. Thank you.
Thank you, Dr. Jembu. So now we move on to the Q&A session. So the first question which we have is from Chandan. Will there be any major difference in place when it comes to poly and mono panels?
Can you repeat the question?
Will there be any major difference in place when it comes to poly and mono panels?
You mean bifacial? I think they meant bifacial. See, means bifacial you'll have better output. That is a advantage of that. Where you have got a space is less. If you want to get more output, we can go for this bifacial. There is no polyfacial actually, only bifacial. Both side only can produce actually. But the other one, cost-wise, the other one is less. But bifacial, cost-wise, little more, but your output will be around 30%. So wherever you have got a space constraint or you want a better efficiency, you can go for a bifacial. Shiva, you want to add something?
Yes, sir. Actually, there will be polycrystalline, monocrystalline type of cells. Apart from that, there will be thin film solar cells also. If you go with monocrystalline, the efficiency will be higher compared with the polycrystalline. The number of panels required for monocrystalline and polycrystalline will get varied. Based upon that reason, we'll go with the monofacial rather than polycrystalline solar cell.
Okay, good. I mistook the question actually. Okay, you're given a correct answer. Okay.
Thank you, sir. I hope that answers your query, Chandan. The next question which we have is from Jay Anam. He asked that, sir, since the government is encouraging to fix solar at our homes by giving huge subsidy, how we can like fetch benefits who lives in skyscrapers, basically?
Yeah, we can see the government is giving facilities as he himself is telling. So we have to approach the concerned authority and in Chennai also many people are going for this actually because the payback period within 2 or 3 years they are able to get the payback period actually. See whatever you are invest, you will get back within 2 or 3 years. You'll be able to. That is an advantage. But if you the concerned authorities you can approach, they will guide you.
Okay, sir. The next question is from Kesar Ali. He asked that in the design of wind and solar power plants, what type of latest software is used?
See, for solar, we are using PV60 is the latest software we are using for solar actually. In industries, we are using for design A to Z, we can use PV60 for the solar generation. And for wind, we can use Shiva, we can use SAMs. And what is the other one?
We can use SAM, but the prediction level, so that company manufacturer will have different tools.
Okay.
So wind is not that much freely available softwares.
Okay.
We have only up to now SAM is the available software as a open source.
Which has got a limitations. Open source, but it has a limitations.
Limitation.
Yeah. But for solar, you can use PV60 is a very good software, which we generally while designing L&T also uses a lot of this PV60.
Yeah. Yes, sir. Solar PV60 they are going to use in our projects.
Okay, sir. The next question is from Vipin. He asked that how would we can increase the penetration of solar in direct and fault level increased due to the rooftop on PV panels, basically photovoltaic panels.
Can you repeat the question? I could not understand that.
Yeah, he asked that how would we can increase the penetration of solar and fault level increase due to the rooftop PV panels.
Okay. Rooftop, you can take this question, Shiva.
Sir, in rooftop, we will have only a fixed tilt position only will be placing.
No, he's asking about the penetration in the grid actually.
That is what, sir. So the level of power which is inducted due to the fixed position, So the current level will be sometimes, so it will be difficult to, it's a some type of challenge will be there in rooftop.
Okay, so basically he is mentioning about
Penetration means, so that will depends upon the area of rooftop you are going to take. So if it is a large amount of rooftop available on the home, so it will depend. So like 1 kilowatt or 10 kilowatt like that. If it is available, it will create some amount of power injection. So power injection means, so it will comes the it is not fixed. If it is a tilted position, it's a fixed tilted position. So because of the fixed tilted position, so the power level, whatever they are going to get, so that is fixed.
okay, and the same scenario goes with the distribution transformers also.
So in small rooftop and all, so they won't go for big transformer level connection on them. So small level rooftop, they won't go for transformer connection.
Okay, got it. I hope that answers your query, Vipin. The next question is from Chandan Shinde. He says that I have seen one society in his vicinity who has planted small turbine on their rooftop. Is it possible to have such for power generation also?
Small wind turbines, so they can install on the wind, small turbines they can install, but the power
The small turbines you can use for generation, because in the microgrid, we are using combination of solar and small. In campus and all, we can form a microgrid, wherein the rooftop you'll have a solar and wind combinations we are using for microgrid, and it can generate power. The wind turbine can generate power.
Okay, sir.
Yeah.
The next question is from Pratap. He asked that vertical axis wind turbine or horizontal axis wind turbine, which one will yield maximum like energy with less velocity?
Actually, horizontal wind axis turbine will have a limited speed. That is, that will have some cutoff and cut-in speeds will be there. So where the generator size and all will be more for this horizontal, whereas for the vertical axis wind turbines, they are in the research level where high speeds can be converted into electricity, but they are not that much into the market up to now. Wind axis turbine. Vertical axis wind turbines are not well in the market. So they are in the research level only. The wind turbine size will be more.
Okay, sir. So I'll request you to drop your queries in the chat box. We will answer them. We will reach out to you guys and we will let you know the solutions for the same.
Thanks,
Over
thanks,
to
Chan.
you.
Yeah. Thank you, Jambu sir and Sivaprasad sir, and LNT team and our all the participants. So I will I will take 5 more minutes of you and present you that two of unique programs that we have launched in collaboration with LNT. So if you
Okay.
can see my screen, uh, our university, Ajeenkya DY Patil University, Pune, we launched two MTech programs, one in infrastructure engineering and second in renewable energy engineering this year.
Okay.
So these are some of the features of this program,
Okay.
as similar to all other MTech programs. It is for the duration of 2 years. The campus is our Pune campus. We have a full-fledged university there with more than 4,000 students currently studying. L&T
Okay.
EduTech are our industry and knowledge partner. We have a good amount of employment opportunities with L&T. The students will also get a chance to intern there. They can also visit the L&T various facilities. As you all know that L&T is present in most of the areas our country operates in. from infrastructure to energy to real estate to manufacturing. Program fee for these MTech programs are 4 lakhs per annum.
Okay.
Coming to the detail of these two programs. So in infrastructure engineering, we cover most of these modules,
Okay.
like airports and seaport engineering, design and construction of highways, metro rail transportation and design and construction, deep excavation and pile foundation, and bridge engineering. And
Okay.
all the modules are similar to most of you. If you come from civil engineering background and mechanical engineering background, you will find a lot of similarities there. Coming to the MTech renewable energy engineering, few of the modules that we cover in this program are renewable energy and power evacuation, applied industrial IoT. IoT is short for Internet of Things, plant automation, deep excavation, smart grid technologies, and green energy systems. So we have started our admission process for this year. So, and our applications are filling shortly. We have
Okay.
limited number of seats for the students. So I will
Okay.
request all our student participants to fill the application form, and please reach out to us on these coordinates. And we look forward to a good number of application from our students who can participate in these MTech programs and also contribute to the our country's nation building endeavors that we have taken in our recent years. So, and for other questions, please drop us an email on these coordinates. So we will try to resolve your and get in touch with you through email as well as calls and messages. So to wrap it up, so thank you experts from L&T, and thank you all our student participants and various participants from academia and industry. And I will we will wait for a couple of more minutes. If you have any questions, please drop in the chat box. Otherwise, you can write to the email of Ishan Kurup's email ID, who is our head counselor. Thank you, everyone.